In this video course, we're going to be building a simple to-do list REST API wired up to a SQL Server database using ASP.NET Core and Entity Framework. If you like this type of content and would love to see more, please leave a like and subscribe to the channel. For this build, we're going to be using the following tools: Visual Studio Code, the .NET SDK, and an installation of SQL Server 2022. So make sure to have them installed if you want to follow along. So to begin, we'll open a terminal window and create a new folder to hold our project using the make dir command. We'll call the folder To-Do App. Next, we'll cd into the folder and create a .NET Web API project using the .NET CLI tool. To do this, we'll type .NET New Web API and use the N flag to specify the name of our project, which will be todo.api. We'll also add the controllers flag to ensure that our project is created with controllers. Once we run the command and our project is created, we can navigate into the todo.api folder and type code followed by a period to launch VS Code in that folder. Now, if we take a look at our project inside of the Solution Explorer, we can see that we have a sample weather forecast controller that returns some sample data. By the way, if you do not see the Solution Explorer and only have the default folder view, make sure to install the C# Dev Kit from the Extensions Marketplace. Back in the Solution Explorer, we can also see a todo.api.http file. These .http files allow us to test our API easily in VS Code without having to use external tools like Postman. To use them in VS Code, you'll need to install the REST client extension from the Marketplace. Once that's installed, we can go back to the .http file, and here we see that we have a simple GET request set up, and above it you should see a send request link, which is from the REST client extension we just installed. So we can test this endpoint by clicking the send request link. However, we need to start up our API first, or we'll get an error message that the connection was rejected. But before we do that, let's get rid of this red squiggly line by changing the name of our host address variable to something that doesn't have periods in it. Now we'll open a terminal window inside of VS Code by pressing the Ctrl+ backtick keys, or using the menu bar at the top of the screen. To run our API, we'll type the .NET Run command and press Enter. Once the API is running, we can now click on the send request link in our HTTP file, and we receive a 200 OK result with the sample data from the Weather Forecast Controller class. Now we'll create our to-do controller and start working on our API. So over in the Solution Explorer, we'll click the new file icon on the controllers folder. From the list of templates, we can search for API controller and hit enter. We'll name our controller to-do controller and hit enter. That will create our empty controller class. Before we proceed, we can place the cursor in the namespace and press Ctrl+% to bring up the quick actions and switch to using file scope namespace for a cleaner look. We'll also get rid of the weather forecast controller as we don't need it anymore and remove the weatherforecast.cs file as well. Back in the to-do controller.cs file, we'll now create our first controller action method to get all our to-do items. So we'll create a public async method that returns a task of iActionResult and call it getAll. Inside it, we'll just return a 200 OK result for now. We'll also add the HTTP GET attribute above the method so it gets called when a GET request is made to the API/to-do route. Now, even though we're not returning any data yet, we can test that our controller is set up properly. So we'll go to our .http file and change the route for this GET request to go to API/to-do instead of weather forecast. If we run the API again and send the request, we receive an empty 200 OK result, which is what we're returning from the controller action method. So before we can begin returning data from our API, we need a model to hold our data. So in the Solution Explorer view, we'll create a new folder and call it Models. Inside the Models folder, we'll add a new C# class file and name it To-Do Item. Inside the class, we'll create a very simple model with just two properties. So we'll have a name property, which will be of type string, and an isCompleted property of type bool. We'll also create a constructor to initialize these properties. For this, we can use the primary constructors feature in C#, which allows us to specify parameters after the class name, and then we can initialize our properties with the values passed in. In addition to our model, we'll also need to create a DTO or data transfer object for sending data out from the API. So we'll create a contracts folder in the Solution Explorer and add a new record called To-Do Response using the primary constructor syntax. Now back in our To-Do controller, let's return some sample data in the getAll method. So we'll create a new To-Do items variable and initialize it to a list of to-do items. Next, we'll create a response variable and convert the list of to-do items to a list of to-do responses using the convertAll method from LINQ. Then we can pass that list to the OK method to return our sample data. To test this, we'll make sure our API is running, and over in our .http file, click the Send Request link. As you can see, we still get back a 200 OK response, but this time we also receive our list of sample to-do items. We'll begin by installing the NuGet packages that are necessary for using Entity Framework in our project. So we'll open up the terminal in VS Code and using the .NET CLI, we'll install the Microsoft.Entity Framework Core NuGet package. Next, we'll add the Microsoft.Entity Framework Core .SQL Server package. And finally, the Microsoft.Entity Framework Core .Design NuGet package. With these installed, we can start setting up our data access using Entity Framework in our project. However, before we proceed, we need to add an ID property to our To-Do item model, so it can be used as the primary key for our database table. So we'll head back to our todoitem.cs file and add an ID property of type integer. We'll also initialize the property using the primary constructor. Next, we'll head over to the To-Do Response DTO and also add an ID property. In the To-Do controller, we'll add in some sample IDs in our sample data so the project still builds. And finally, we'll also add the ID property in the action method, where we map from the model to the DTO. With that out of the way, we'll now create a new folder in the Solution Explorer and call it Data. Inside the Data folder, we'll create a new C# class and call it To-Do DB Context. We'll switch to using file scope namespace and have our class inherit from the DB Context class from Entity Framework. We'll also add a constructor using the primary constructor syntax and pass the DB Context options to the base class as required by EF Core. Then, inside of our To-Do DB Context class, we'll add a DB set property of our To-Do item model called To-Do Items. With our DB Context class set up, we can now register it with a dependency injection container in our program.cs file. But before we do that, we'll need a connection string to connect to a SQL Server database. So we'll open our appsettings.development.json file and add a new section called connection strings. Inside it, we add our connection string called default connection. Now we'll return to the program.cs file and wire everything up. So we'll call the addDBContext method on the service collection and pass in a Lambda function where we'll call the useSQL Server method on the options parameter. This method takes in a string parameter, which is the connection string of the database we want to connect to. So we'll point it to the connection string we added earlier in the app settings file using this syntax. Now to test that we've wired up everything properly, we'll inject the DB context directly into our to-do controller class and use it in our getAll endpoint. But first, we need to create a migration and create our database in SQL Server. So we'll open up the terminal window and create a migration using the .NET EF tool. If you don't have the .NET EF tool installed, you'll need to run this command to install the .NET EF tool globally on your machine. Then we can run .NET EF migrations, add followed by the name of our migration, which we'll call initial and press the Enter key. This will create a migrations folder, and inside it, we can see the migration we just created, which will create a new to-do items table in the database. With the migration created, we can now create our database by applying the migration using the .NET EF database update command. Once that runs, Entity Framework will create our database for us, and we can check that it worked by connecting to our SQL Server instance. We can do this from VS Code using the SQL Server extension from Microsoft. So make sure to have the extension installed, and then we can select the SQL Server panel from the sidebar. Under Connections, we'll click on Add Connection, and in the dialog that opens, we can see this load from connection string option. So we'll copy our connection string from our appsettings.development.json file, and back in the Add Connection dialog, we'll click the Load from Connection String link and paste in our connection string. We'll make sure to unescape the string by removing the extra backslash, and then we'll click the Load button. Now, we can scroll to the bottom and click Connect. If we look into the Tables folder, we should see our To-Do Items table. If we right-click and select Top 1000, we see that the table is empty as expected. So we'll manually insert some seed data for testing. So inside of the SQL editor, we'll remove the select query and add an insert statement to add 2 sample to-do items into the database table. If we run the query, we see that it succeeds, and if we run the earlier select query again, we now have 2 items in our table. Now that we have our table set up, we'll return to our to-do controller class and inject an instance of our DB context using the primary constructor syntax. Then, inside our getAll method, instead of creating a new list of to-do items, we'll call the toList async method on our to-do items DB set from our DB context. We'll leave the rest of the method as it is, as we still need to convert the list of to-do items to our to-do response DTO before returning the data. Now we'll run our API project once again and go back to our .http file. If we send the GET request, we now get back data directly from the database. So back in our to-do controller, we can see that we're currently injecting the to-do-DB context directly into the controller and using it in the getAll method. But before we add the rest of the CRUD functionality for our to-do items, let's make our code cleaner and more maintainable by adding a service layer. So in our Solution Explorer, we'll create a new folder and call it Services. Inside of the Services folder, we'll create an interface, which we'll call iToDoService. Inside the iToDoService interface, we'll add in a method signature for our getAll async method, which will return a task of list of to-do items. Next, we'll create a new class inside of the Services folder and call it ToDoService. We'll have it implement the iToDoService interface and use the quick actions to generate the method stub for our getAll implementation. Now, we can inject the DB context into our implementation of the IDA-Do service interface and use it to retrieve the data from the DB. So we'll inject the to-do DB context via the primary constructor, and in the getAll method, we'll remove the placeholder throwNotImplementedException call and replace it with a single line of code, which will return a list of to-do items from the DB set. Before we can use our to-do service in the to-do controller, we'll need to register it with our service registration collection in the program.cs file. So we'll open the program.cs file, and below the add-DB context call, we'll register our to-do services using the add-scope method. This tells the service provider to use an instance of the to-do service class whenever we inject an IDA-Do service. So now we can head over to our to-do controller, and we'll replace the to-do DB context we're currently injecting with our IDA-Do service interface. Inside the getAll method, we'll now use the getAll async method from the to-do service to get our to-do items. With the transition complete, we'll test that it still works by running the API and sending the request in our .http file. And sure enough, we're still getting back data from the database. With our service layer in place, we'll begin working on the rest of the CRUD methods for our controller. So we'll be adding methods to allow us create to-do items, retrieve a to-do item by ID, and update and delete existing to-do items as well. So we'll head back to our IDA-Do service interface and add a couple of method signatures for the new functionality. For the create async method, we'll take in a to-do item and return a task with no result for now. For the get by ID async method, we'll take in an ID and return a task of nullable to-do item. For the update async method, we'll take in both an ID and a to-do item and return a task of nullable to-do item. And finally, for the delete async method, we'll take in an ID and return a task of bool. Now we can head over to the to-do service.cs file, and we'll notice a red squiggly line here because we're not implementing all the method signatures from the interface. So we'll use quick actions to generate the placeholder implementations for the new methods. So we'll begin with the create async method, where we'll simply call the add method on our to-do items DB set in the DB context, and then call the save changes async method to commit the changes. Next, we'll implement the get by ID async method. We'll use the find async method from Entity Framework to grab a to-do item from the database with a matching ID and return that. The find async method will return null if no entity with that ID is found in the database. We'll return to the update and delete methods in a moment. But first, let's add some new endpoints in the to-do controller and make use of our create async and get by ID async methods from our to-do service. So back in our to-do controller class, we'll add a new action method that also returns a task of iActionResult and call it create. We'll decorate it with the HTTP post attribute so it gets hit when we make a post request to API/to-do. For our create endpoint, we'll need to pass in an object containing the data we want to save to the database. So we'll open the contracts folder and create a new DTO. We'll add in a create to-do request record with name and is completed parameters. Then in our create action method, we'll get in a create to-do request as a parameter from the body of the HTTP request. Before we proceed, we'll open the to-do item model and remove the ID parameter from the primary constructor, as we no longer need to set it manually. Back in the create method in the controller, we'll create a new to-do item object from the data passed in through the request parameter. Then we'll await a call to the create async method from our to-do service. Next, we'll return a created at action result and pass in the name of the get endpoint, which we'll soon add, the newly created ID of the to-do object, and the rest of the properties in a to-do response DTO object. While we're at it, we'll also create our get endpoint for retrieving a single to-do item. This will also return a task of iActionResult, but will take in an ID parameter. We'll add the HTTP get attribute and a route parameter, which we'll call ID, and which will be an integer. So this method will get called when we make a GET request to API/to-do/an ID, such as 1 or 2. Inside the method, we'll retrieve the to-do object using the getById async method from the to-do service. If the to-do is null, we'll return a not found result. But if we get back a to-do item, we'll map it to our DTO response and return an OK result with the to-do response. With both endpoints set up, we can head over to our .http file and begin testing that they work properly. Since we already have some to-do items in the database, we can easily test the getById endpoint. So we'll copy the request block for the getAll endpoint and paste it below. We'll modify the route and add an ID parameter of 1. If we send the request, we get back the to-do item with an ID of 1 from the database. If we change the ID to something like 5, we get a 404 not found response, as no to-do item with a matching ID exists in the database. Next, we'll add a new request for the create endpoint. So once again, we'll copy the getAll request and paste it below the getById block. We'll change the method type to post and add in a content type header, which will be application/JSON. Below that, we can add the body of the request in JSON format, which will get bound to our create to-do request DTO. If we send the request, we get back a 201 created response with a location header, which tells us where to access the resource we just created. We can also see the newly created to-do item with an ID of 3. So if we go back to the .http file and run the getAll request, we'll now see that there are 3 to-do items being returned from the database. So back in our to-do controller class, we'll add a new action method for the update endpoint. We'll decorate the method with the HTTP put attribute and a route parameter of ID. For the update endpoint, we'll be taking in the ID from the route, as well as an object containing the data for the update operation. So we'll open the contracts folder and create a new record, which we'll call update to-do request. It will contain the same properties as the create to-do request for now, but we'll keep them separate as that might change in the future. Now we can head back to the update action method and have it also receive an update to-do request parameter. Before we proceed though, we need to implement the update async method in our to-do service. So we'll open the to-do service.cs file, and in the update async method, we'll remove the throw not implemented exception call. In its place, we'll use the find async method to get an existing to-do with a passed-in ID from the database. If no to-do item with that ID exists, we'll return null from a method. If we successfully retrieve an existing to-do item, however, we'll set its name and its completed properties to the values from the data passed in to the update method. We'll commit the changes by calling the save changes async method on the DB context and return the now updated existing to-do item. Back in the to-do controller, we can now use the update async method in the update endpoint. So first, we'll map the data passed in from the update to-do request to our to-do item entity. Then we'll call the update async method and pass in the ID parameter from the route and the to-do item. We'll put the data returned from the update async method into this updated to-do variable. If the updated to-do is null, we return a not found result, as that means that no entity with a passed-in ID was found in the database. If we successfully get back an updated to-do, we'll map it to a to-do response object and return a 200 OK result with the updated to-do item. To test that this works properly, we'll open up our .http file. First, we'll make sure the API project is running, and then we'll send the getAll request. We can see that we currently have 3 to-do items being returned from the database. So to test our update method, we'll try to modify the data for the third to-do item with an ID of 3. So we'll copy the create request we added and paste it below. We'll change the HTTP method type to put and add a route parameter of 3. Next, we'll modify the JSON data and change the name property to say my updated third to-do. We can also change the isCompleted property to true. Now if we send a request, we get back a 200 OK result, and you can see the updated to-do item from the database with the changes we made. We will now implement the last endpoint needed for completed CRUD functionality, the delete endpoint. So in our to-do controller, we'll add a new action method called delete, which will take in an ID parameter. We'll add the HTTP delete attribute with a route parameter of ID. Now we can head over to the to-do service.cs file and implement the delete async method. So we'll remove the placeholder code, and just like the update method, we'll use the find async method to retrieve the to-do with a passed-in ID from the database, if it exists. If find async returns null, then we'll return false, indicating that the delete operation was unsuccessful. If we get a to-do item, we'll call the remove method on our to-do items DB set and pass in the to-do we want to delete. Then we can call save changes async and return true. Back in the to-do controller, we await a call to the delete async method and store the result in a variable called deleted. If deleted is false, we'll return a 404 not found result. Otherwise, we will return a 204 no content result, which is the standard for delete endpoints. To test our delete endpoint, we'll head back to our .http file and make sure our API is running. Then, we can add a new to-do item using the post endpoint. So we'll modify the JSON body and set the name to temporary to-do item. Then, we'll send a request, and we get back a 201 created result. Our temporary to-do item has an ID of 4. So in the .http file, we'll now add a new request block for the delete endpoint. So we'll copy the getById endpoint and paste it below. We'll change the HTTP method to delete and change the ID route parameter to 4. Now if we send a request, we get back a 204 no content result as expected. And if we run the get all request, we see that no longer have the temporary to-do item in the database. In the next video, we'll modify our project and add authentication using JSON Web Tokens, so users can log in and see only their to-do items. If you enjoyed the video, please give it a thumbs up and subscribe to the channel. Thanks for watching, and see you in the next one.